guys, welcome back to my channel. In this video we're going to talk about intelligent agents. So every time we talk about self-driving car, it always involves the concept of intelligent agent. So let's go ahead and explore this topic. So first of all, let's start by answering the question, what is basically an agent? So an agent is basically, an entity that can perceive its environment through sensors, and then it can act on the environment using actuators. So in fact, interacting with the environment and adjusting it accordingly is what we call an agent. Okay, so the agent, it can be a human using eyes and hands, or it can also be a robot using cameras and motors. Okay, so let's go ahead and talk about the agent function. So the agent function is basically what we call the brain of an agent. Okay, because it takes everything that it senses so far and it's gonna map it to an action. Okay, and this is where the AI comes in. We build an agent program, a piece of software that implements this function. So the agent is basically equal to the architecture plus the program itself. Okay, so here we have an example of a vacuum cleaner agent. So we have, in the squares you can see the square A and square B. We have some dirt and we have the vacuum cleaner agent over here. So here the percepts in this case are the location and the contents over here, and that is basically like I said, the square A, and it's dirty, right? And similarly there's square B, and which is dirty as well. Okay, and here the actions that the agent can take is, of course, it can go left, it can go right, it can suck, it can do no operation, right? Because the agent is in here is the vacuum cleaner. Alright, so these are the percept sequence we have and the actions we have. Okay, so as you guys can see, so if in the square A, if it's clean, so then it's gonna the agent is gonna go ahead and move to the right, and if it's dirty, then of course it's gonna go ahead and suck it. But if it's in B and if it's clean, it's gonna go ahead and move towards A, right, towards left, and it's gonna go ahead and suck that one if it's dirty. So here if we apply the function here, that if status is equals to dirty, then return suck, right? Else if location equals to A, then return right. Else if location equals to B, then return left. So what do you guys think? Is this a rational agent? Because every time the square A is dirty, it's gonna clean it. Every time the square B is dirty, it's gonna clean it. And if it's in A and it's cleaned, then it's gonna move to B and to clean that one, right? And similarly, it's like moving back and forth and sucking. So what do you guys think? Is this a rational agent? Is this what we mean by a rational agent? No, this is not a rational agent because it is not adapting to the environment. Because if there's a change in environment, for example, if both of the squares are clean, what is it gonna do? So that's why this agent over here that we have of the vacuum agent, this is not a rational agent. So this brings us back to the concept of rationality. Okay, so what is rational at any given time? It depends on 4 things. Okay, so number 1 is the performance measure, how the agent is performing, and the number 2 is the agent's knowledge about the environment, and number 3 is the action that agent can perform. Okay, alright, so to design a rational agent, we must specify the task environment, which includes the performance measure, the environment itself, the actuators, and the sensors. So this is PEAS. Okay, so this is also called the PEACE framework. Okay, so let's go ahead and do an example of PEACE framework. So here, if we have an example of a self-driving car, what do you guys think is the performance measure over here? Like, how are we going to measure the performance of the agent? So the performance of the agent can be measured using the safety, right, the smooth driving, the fuel efficiency, and the environment. So the environment over here is the roads, the traffic, the weather, and the actuators, which are basically the tools which help the agent to interact with the environment are the steering wheel, the brakes, the accelerator, and the sensors here are of course the cameras, the GPS, the radar, and etc. Next, let's go ahead and do an example of internet shopping agent. So the internet shopping agent, if you guys don't know, it's also called a comparison shopping agent. This is basically a type of software agent. It can help users to find and compare products online. It automatically searches multiple e-commerce websites, and it's gonna find like best price, available reviews, or other criterias users might care about. So it's basically like comparing prices and availability reviews and etc. So here, how are you going to measure the performance of this agent? So to measure the performance measure, we have price, quality, appropriateness, efficiency, and the environment that it's operating in is the current and future websites, the vendors, the shippers. The actuators in this case are the display to users, the URLs, the forms that you are filling, and the sensors here is of course the HTML pages that you're visiting, the return form content, the page metadata, product listing, reviews, search engine results. So these kinds of things goes into the sensors. Okay, so now that we understand how an agent interacts with the world, right? It interacts with the world through the performance measure, sensors, actuators, environment. So let's go ahead and dive deeper into this concept. So not all environments are basically the same. Some are simple and predictable, while others are dynamic and unpredictable. So to design smart agents, we need to understand what kind of environment we'll face. So for this, to be able to understand the type of environment, we have to explore the types of environments, right? So let's go ahead and explore the types of environments. Fully observable environment, the agent sensors give it complete access to the entire state of the environment. All the sensors are working and the agent knows its environment very well. Okay, and so an example of that would be an AI playing a chess game, because the agent can see the entire board, including all the pieces, their positions. There's nothing hidden from the agent, right? And next we have partially observable. So partially observable means the sensors are somewhat working. Okay, so the agent has limited information due to the due to the imperfect or incomplete sensors. So an example of this would be our classic vacuum cleaner example. So vacuum cleaner robot that can detect whether the current square is dirty or clean, right? But it cannot see the rest of the room. It only has access to these two tiles, right? So this is a partially observable environment. And next we have unobservable. So unobservable environment means there's no sensory data, there's no sensory input at all. Okay, and an example of this would be a self-driving car, but a self-driving car with no sensors. Okay, so here, if it does not have any sensors, so it is unobservable. It is an unobservable environment. It cannot detect traffic, roads, or passengers, essentially operating blindly. Okay, so this is what you call an unobservable environment. So let's move on. Okay, so now we have single agent versus multi-agent. So a single agent means it's by itself, only one agent is actively operating the environment. No other agent affects the outcome. Again, an example of this would be our vacuum cleaner robot, cleaning the room by itself. There's no one else here. There's the only single agent over here, right? And as the name suggests, multi-agent. Multi-agent means multiple agents interacting with the environment. So here in the chess game, so you have two players because the machine is not like playing by itself, it's playing with an opponent, right? So every time you have like an example of two players or two or multiple players, so that's like multi-agent environment. Another example of the multi-agent would be a self-driving car, because it's not interacting with itself, it is interacting with the other cars and passengers and stuff. Like it has so many other agents that it's interacting with, right? So it's not by itself. So that's what that is a multi-agent as well. Alright, so let's move on. So we have deterministic, non-deterministic, and stochastic. So in the deterministic environment, the outcome is always the same given the same input and action. There's no uncertainty. So okay, so an example of this would be in the calculator, for example, you go ahead and press 50 plus 50, so it always gives 100, right? There is no uncertainty, there is no randomness involved. The result is fully determined by the input, right? Okay, so and non-deterministic is when multiple outcomes are possible. We don't know the probabilities of each. We just know like there's uncertainty here, but we don't know exactly the probability. So an example of this is like if we say it might rain tomorrow. We don't know like exactly, but we know there's a possibility. Okay, so every time like there's a possibility, but we don't know like the probability of it, so that's non-deterministic. But when we know the probability, that's when we call it stochastic. Okay, so here the example is like if we say like if there's a chance of 25% rain tomorrow, so that means it's stochastic environment. All right, let's move on. So now we have episodic versus sequential. So episodic is when the agent does one episode and does not affect the future episodes. Okay, by that I mean like the email spam filter. The agent checks like each email individually, decides if it's spam or not. Like it doesn't matter if it did or what it did for the previous emails. Like there's no memory needed, right? So whatever it's doing in the previous episodes, it is not the previous actions are not dependent on the future actions, right? However, if the future actions are dependent if the previous actions are dependent on the future actions, then that is the case of the sequential environment. So every future action depends on the past actions, because here in the chess game, your every current move depends on your future move, right? So this is sequential. And talking about static, dynamic, and semi-dynamic. So in a static environment, static means the environment is not changing. So like there's no change in the environment while the agent is thinking. Everything stays the same. So an example of this is in the puzzle game, like while the agent is thinking, there's no change in the environment. The puzzle is not gonna change. Okay, it's just gonna remain there, right? What it can change. Whereas in the dynamic environment, the environment, it's gonna change while the agent is thinking. Okay, so an example of this is the automated taxi. While the taxi is calculating its next move, other cars may move, signal may change, pedestrians may appear. So the environment, it is constantly changing. So while the agent is thinking. So that's why we call this dynamic, because it's constantly changing, and static because it was not changing. And semi-dynamic means the environment, it's not changing, the environment is still staying the same, but the agent's performance score, that changes with time. Okay, and an example of this would be a timed quiz or exam. The questions, they don't change while you think, but your score, it decreases over time if you don't answer your questions quickly, right? And another example would be a game with a timer in a time game where you lose points for taking too long, the environment doesn't change, but your performance, it get worse with time, right? So with everything explained, I have an example for you guys here. This is a question about the internet shopping agent. What do you guys think? The environment that it's in, is it observable, is it deterministic, is it episodic, static, discrete? Let me know the answers into the comment section, and I will provide the answer to these in my next video. So I'll see you in the next video. If you found this video helpful, please subscribe. Thanks for watching. Bye.